So hello everyone, welcome to my talk. This is my first talk at DevGAMM and I'm really excited about it. And today I'll be talking about, how do I, sorry, it's working now? Okay, sorry about that. So yeah, today I'll be talking about step up your engineering game and I will be focusing on, uh, just a minute. Sorry, I think some problem with this one. Yep. So I'll be talking about software engineering in games, thinking about optimization, writing unmanageable code, and leaving company, why tabs are better than spaces, why Windows is better than Mac or Mac is better than Windows. Just kidding. None of those, of course. So before I continue with my talk, I will introduce myself a little bit. So who am I? I'm Jisan Haider. I am working at Kolibri Games. I'm originally from Bangladesh and based in Berlin. And I am working at Kolibri Games as a senior Unity developer and in the core tech team. So what I do usually day-to-day life in Kolibri Games is that I work on all the live games that we have. One of our popular games is Idle Miner Tycoon, and another one that has already is doing really great, that's Idle Bank Tycoon. And my day-to-day work includes like fixing crashes, ANRs, optimizing part of the game that is very important for health metrics in different dashboards like Google Play and all those things. Also, I design and implement new systems and internal SDKs we try to improve our technical standards. So yeah, on top of that, I've been in the industry for around 9 years or something, 9 years plus. I have also experience in full stack and distributed systems, so I have also worked on multiplayer games. Also one of my game also that I worked on during COVID time hit like 4 million daily active users something. So yeah, and my specialization is mostly Unity and optimization and all those things. So yeah. So coming back to the topic, sorry about the microphone. Coming back to the topic, let's talk a little bit about the background of the talk. Step up your engineering game. How did this came up and why I'm talking about this? The background is that learning game development right now is a really easier than it used to be back in like 2015, 2012, and 2013, back in those days. Right now, due to internet and all those Indian YouTube channels and all, learning programming is really easier now. And also learning, picking up a game engine, then you learn tutorials and resources, it's there all over the internet. And back then it wasn't that easy, right? So from that point of view, I want to talk about like if you want to make a small games, you can pick up scattered tutorials in the internet. There are communities, forums. You pick up helps from those places. You copy code from Stack Overflow and don't know how it works, but it works, and you make a small game. At least I did. I made multiple small games here and there in mobile games. That's how I started. But interesting fact is, do we all start with small games? No, at least not me. And I know 69 others who didn't. We all started with Call of Duty, GTA, Vice City, and all those things. Hey, I want to make my own Call of Duty. And finally ends up with Call of Shitty or something like that. Nothing like that. So, yeah, I mean, that's how I thought about like learning games has becoming easier, but every steps after that are harder and harder. And interesting fact is that at some point we see people not growing anymore. It's like you join, maybe you join a game studio, you join a small indie team and all those things, but at some point you see that the growth starts like this, but then it goes like this. You don't grow that much day to day or month or every year or something like that. And coming from that point, this is my talk. The overview is going to be how you grow as a software engineer in mobile game development. addressing some of the common challenges in the career progression and some key takeaways. I'll be talking about my 3 golden rules that I follow personally and that has brought me till this point I've come in my career. And lastly, I'll keep enough time for Q&A. All right, so a question that also comes up, why is growth hard? Because it has multiple contexts from game studios like small studio, mid-sized studio, big studios, and also solo dev. There are different contexts. But why is growth hard? Why does it even matter? That's a big question. So the thing is that among all those contexts I've talked about, the important fact here is that the career transitions in all these contexts, there is one common thing. That is, the more you grow, the career transitions are increasingly abstract responsibilities and broader ownership. Why? Because what do I mean by that? I would say is that the more you grow in your career ladder, you take up more abstract responsibilities, you have broader ownership, and that is like different in different contexts, I would say. Let's say if I talk about indie studios, then you have to wear multiple hats. When I had my own game studio back in those early days, I was doing programming and also I did video editing as well. I didn't know, but I had to pick it up somewhat, like I need to do it for the team. I need to do, let's say I had to bake lights in the game. I didn't know, I knew a little bit of modeling and all those things, but I was not sure how to bake lights and all those, but I had to do it. That was like part of the responsibilities that came up along with that. And interesting fact is that when you transition from junior to mid to senior, senior to lead to principal or manager, the hardest part of this transition is that it's not always purely skill-based. It's not always purely skill-based, and it also requires you to shift in how you think, act, and influence. Why I say that? Because when you think, act, and influence, it's a very broad concept. So let's say you are starting as a junior engineer, and now you have to think in a different context than the lead should be thinking. Because you are going to be thinking as part of your squad, your team, whatever you call it. You need to think from that perspective, and then you need to act based on that context and perspective, and then you need to influence your team from your position. And then once you grow, let's say you become a senior or lead or manager, the context also grows. It doesn't shrink, it just grows more. Maybe you will see your lead not coding that much like his early days, but he will be, like thinking, acting, and influencing in a much broader perspective and context, because let's say your lead will be meeting with multiple teams internally in the company. Your lead will be in the meetings with some external teams as well. Lots of other meetings. They need to think and act and also influence based on those contexts. So yeah, that's why I said like the hardest part here in the transition is that it's not always purely skill-based. It's also how you think, act, and influence. So let's say we have defined the problem. What's next? So let's say I'm a senior or mid-sized engineer. How do I grow? What's my career path gonna look like, and how do I plan my career so that I wanna be a better engineer? How do I do that? Right, so in this today's talk, I will be talking about some of the technical skills that I would love to see when a person is growing as an engineer, and also the 3 golden rules I was talking about all these times before. It's not think, act, influence. It's something else. I'll come to that. But let's start with the technical skills. So if I'm in sync, yeah, right. So what does a skilled engineer looks like? It's like always you know that it's about mastering algorithms, data structures, design patterns, all those things. We hear that in the job post as well and all those things. But what do I mean by mastering algorithm, data structure, design patterns? It's really important when you start out in your career because it's a basic thing. It's like one of the bread and butter of an engineer. If you don't know how to plan the algorithm, data structures, and all those things, you cannot grow. That's like the first barrier you need to pass. The interesting thing is that I still see engineers, mid or senior, I would say, they are using wrong data structures till now. Let's say you store a config in a dictionary, but when you're iterating, you're using it, you make it a list, and then you iterate on top of that. That's like a very bad usage. I mean, why? You made it a dictionary. Why do you make it a list in the same frame, and then you iterate from that to get some value and all those things? You should have thought how you're looking into the data. Now that brings like how you're planning the algorithm, which I have seen lots of game developers really don't look into. They all care about how the game is or just making the feature and all those things. But you need to plan that to make your game fast and optimize your game. And all those small data structure conversions from dictionary to list, or let's say list to dictionary in the runtime, it adds up in your game as a garbage, and then it's gonna it's gonna crash in your small low-end devices. And also design patterns that are these are also very important because back when I started, I was like, why do I need design pattern? I can do all with singletons. Singleton here, singleton here, singleton here. Game manager.instance do everything for me in all the parts of the game. And what happened? I had to restructure the whole game after 6 months because it was a multiplayer game. Because I was talking about that I started with my multiplayer game when I should be working on small games to level up myself. But I did. We had to because we committed that to investors and all. There was no way back. And after like 6 months or 7 months, I was there restructuring all those things because I didn't know back then. So design patterns are really important. I mean, in YouTube channel and tutorials, you don't find those things that much. That's a very big problem. I see that there's like some guy talking about MVC, but there are other tutorials as well, like even base pattern, observer, all those observe, subscribe, all those patterns are there. But I see that there's a very big lackings on that part, like how do you design your system? It's something that you learn day by day as an experience. So this is very important, and I'm talking about the first point so long because this is like one of the things that holds you back. So next one is that once you have gone through that or you're mastering your skills, you don't have to be the master, but you need to improve yourself daily. Then comes the second point, that is understanding performance and optimization. You need to understand that games and software, they are totally different because games require you to run things per frame. That's the big catch there. I've seen software engineers, great software engineers, doing stuff in a nice way, but it doesn't run well in the game because let's say that guy did something like main thread.sleep until my service class is ready. What the fuck? If your main thread is sleeping until your class is ready, trust me, this was in production. And I was like, what were you thinking? Because that service class was waiting for internet connectivity, and the connectivity had timeout by default 20 seconds. So the game, if somebody is running the game offline, just imagine what might happen. So offline cases luckily were resolved because he put an internet check. But what he didn't check is in 2G or let's say you are in a subway, you lose your internet and it's going to get stuck for 20 seconds. And you will have a black screen in the game. And and then your product manager is like, hey, why my retention is going down? Hey, guys, do you know what's going on? But they didn't check the basic thing. So understand performance optimization because game runs everything based on frames. You have tight budget, 16 millisecond. If you don't start with that thinking, then at some point you're going to mess up. But if you plan that, hey guys, I'll leave this as a tech debt and I'm gonna come back to this, which most of the times we don't, but we promise ourselves, if I come back to this, then it's okay-ish, because you can say to production that, okay, I must come back to this, otherwise this will have problem, like these things. That's fine, but still you need to understand that. And the next part is architecture for scalability. Why? Because let's say you made a game that saves into some binary file or something in the file system, your save game, that's like a basic thing in offline games. But after 5 years, let's say you see that your game explodes like heavy, and explodes as in like your game has lots of users, your game did really well and all those things. What will happen is that you keep on adding stuff into the save game. Let's say one level requires 20 lines of save game file, let's say, for example. Now if you add up like 10 levels, imagine the scale. It's growing 10x. And at some point, you will have save game file of like 50 megabytes or something, 10 megabytes or something like that. I've seen that, I'm not joking. And that's a problem. Because if you want to do cloud save, if you want to save that to the cloud, good luck on uploading that to the cloud, because that's going to take some time. If you're not in a good internet, then yeah, you will have more fails in cloud save. All those things, all those problems comes up. So you need to architecture your mobile games for scalability, because don't think about what you're going to do now, but just think what will happen if the game scales. For example, let's say at this point of time, your game is relatively new, you don't have lots of config in the game. At some point, you will have lots of configs. For example, like let's say the game is doing really great, you have lots of live offers, you have lots of things that you want to control in the game. So you will end up having configs that is like 50, 60 configs, that's way less, but I've seen more. You will end up with 500, 600 offers for different kind of people, because you will have segments in the game. That's coming from like some of the product perspective I've seen. And just imagine if your game is processing all those data, you need to plan that architecture. And lastly, knows how and when to use multi-threading and parallel programming for optimization. This is a very tricky part, because Unity doesn't let us work on main worker thread that much. I'm talking about Unity because like that's mostly mobile game developers use, but also in case of Unreal Engine as well, I would say that if you know how to leverage your other threads, you don't know like how much more you can achieve. I mean, it brings a new performance for you. And personally, I have been doing that a lot. All I can say from the privacy and all those things from Ubisoft, that I can say this much, that I have used in multiple games in our mobile games, and it's doing awesome. I mean, but you need to know how and when to use multi-thread. The fact is that I'm going to give you a tip as well. If you do MVC or something like that, it's also think your model class as the data container. View is view, of course. Controller is controller. In case your controller is not working with the view classes, just imagine how you can convert your model classes and controller classes into something that works in other thread, because it's handling pure data. It's not handling view classes, so no Unity API, done. You can do all those stuffs in the other thread, and you can have some event-based pattern like observer pattern that's gonna be like, hey, main thread, update this please, and done, something like that. And this is like an absolute gem. It works great, and yeah, you will have a little bit of garbage allocation when you talk from one thread to the other thread. That requires higher knowledge on multiple threads, multi-threading programming. But yeah, you can start with that. That's a very nice tip. So now we know what a skilled game engineer looks like. If you're done with that, there's more. You need to understand the big picture. Okay, so understanding the big picture is that if you're working in a product-based company where you have, let's say, you're not working for any B2B client or something, so you're gonna, or maybe you're doing that, but you're gonna, have a product that is expanding for years after years. For example, we work on Idle Miner Tycoon, that is a game since 2015. It's still growing, and we still work on that. So games like this have different picture, because something that you did back in 2016 may be not relevant now. You might end up cursing developers like, what the fuck, why he did that, why he did that? But you need to understand the bigger picture, that that guy did that back in 2016 because they had to, or based on that time, that technical level knowledge they had, or technical capabilities. Back in those days, Ubisoft didn't even acquire Kolibri games. So they had to do something back then. Then maybe they didn't have the tech. So you need to understand the bigger picture, and based on that, you need to make backend services, multiplayer networking, database, and all those game architectures. You need to understand how systems work. You have to have the system thinking, and architecture that affects user experience. As I was saying, you don't block your main thread for your background services because that affects user. You have to think of system and your architectures, but also you have to think, how does the user interact with my service? Because you're not making any typical softwares that's going to be in the desktop used by some random people. You're making games. You're making games that's going to entertain people. You need to think about that. So maybe you're writing some data platform code or something that sends data to the backend, but you need to think, when I'm sending the data platform, the payload, when I create that payload, what if that payload creates a big spike in the game? I have seen that. Let's say you are going to send some system data like, hey, how much of memory consumption is there till now? Or hey, how much of this, that? So you need to collect data, and during that time you allocate a lot of garbage, and then you send that data. What if that whole process is like causing spikes in the game more often? For example, I've seen people collecting data, let's say, in some frequency, for example. Let's say every 10 seconds you tell me that what's happening, or something like user session active, if the user is still active in the session. This kind of data we collect, we usually do in multiplayer games. We as in like, in general, this is a practice. So you send data back to the server that, hey, user is active or something like that. But you need to think like how your systems is affecting user experience. That's very important. And then comes the last part, developing a game engineering mindset, building for performance, flexibility, and scalability. So as I said, you need to think about like how you do those things beyond code. You need to think in systems, like how each systems work. It's kind of like web development, where people talk about microservices. You can think about in one big box that is your game that has different services, and think about how they communicate with each other without overcomplicating the code. All right, so next slide. So the last thing I would say about technical part, what I've saying, it's like pretty common, but also I'm giving some tips that I've faced from my personal experience. Becoming a problem solver, not just a coder. It's like one of the most important things that can set you apart in the whole team, in the whole company, and wherever you go. Become a problem solver. Because what happens is that most of the time, it's the things that we face in the game, or whatever happens in performance and all those things, it's mostly like how you do stuff. For example, again, I can bring in that main thread thing again, but let's talk about a new example. Let's say you have something that dirties some other thing. For example, let's talk about idle games, because I work on idle games. I will talk about that. So idle games is something where you earn cash or game currency every second, right? Now, what if that's a recurring thing happening every second? Let's think of that as a system. And on the other hand, you have multiple things that can change this. So what will happen is that You make a upgrade to some object, something, let's say in Idle Miner Tycoon, there's some ground worker or elevator or those things. You update that, and that changes this factor that your number is now better, like you're earning a lot more than before per second. Now, we have think of this as a box, and we have multiple of them. Now what will happen is that if you trigger one change, it's changing this guy because you're earning more now. Then there's something else is also looking for that change, and there's like 50, 60 other things that's looking for that change. That's like a common trap in observer pattern. You subscribe to one event 50, 60 times in 50, 60 places, and when you make changes, then that's gonna boom. That's gonna make like 100 millisecond, 200 millisecond spike because there was a massive change altogether. Now, what would you do if you are gonna solve this problem? What I was doing there, that's my small story from my experience. What I did was I was throttling every frame, that you cannot process this event more than 10 times or more than n times per frame. So what we do is, it's kind of like a coroutine. What happens is every frame we divide that thing. It's like time slicing thing. So the keyword is time slice, and interesting fact is you can divide a lot of things in your game that is very heavy using time slices, that I will not let you do more than 2 jobs, more than 3 jobs, whatever it is. So you need to make sure that other system that is looking for this is also based on that it's going to be eventually there, but not just in the right frame. Maybe 3 frames later, 5 frames later, it's fine. User cannot see that difference. User sees that every second that, okay, something happening, but if it's like 4 or 5 frames, it's fine because we see things in 60 frame rate if that's like the, you want to be default. 60 frames, now we have 120 frames as well in some devices. iPhone is already at ProMotion display, so it supports 120 frames. So 3-4 frames, it's fine, nobody is gonna know, but what happens is that you don't do all at once. Also the spike you can reduce a lot. So yeah, so you need to think more beyond as a coder, like how do you solve this kind of problem? And that also is gonna optimize your game a lot. And yep, learning to balance between writing clean code and solving complex game mechanics, that's like one of the last point I was gonna talk about, is that when I did that, the problem is that made the code a little bit complex. I also had to make sure that how do I make it clean, at least readable. So yeah, that I did a lot of things here and there just to make that better, but I had to also balance those kind of things. I've seen people bragging about how complicated their code was. I've seen people over, what I say, just to write clean code, they wrote 10 interfaces, 10 classes for the same thing, just so that like the separation of concern, when solid principle becomes too solid, you have a single responsibility, like breaking them down so much that for one single big picture, big feature, you made 10 classes. That just doesn't work. I mean, that's really bad. So you also need to balance between that. All right, so that's all from my side about the technical parts. I will quickly go to the 3 golden rules I was talking about that will set you apart from the rest of the team. So this is not technical anymore. I've talked a lot of technical things. Okay, I'll stop it, but now it's time to think in a different way. How do you become better in your team? No matter what type of programmer you are, no matter if you are that star kid in the company who is like an absolute genius, or you're just a regular average guy, whatever it is, if you follow these 3 things, it's gonna set you apart in the team. At least you're gonna be one of the person who the company can rely on. And that is being predictable. I'll take a minute and let you guys digest the fact what the fuck is being predictable. Why is it in the engineering talk? Anyone wants to, I will take one answer maybe. What do you think about being predictable? Anyone? All right. Yes, almost there. Anyone else?
You say predictable, but it's more likely reliable. You know that what the person will do and that it will be like right. You don't
Yeah.
have to expect.
All right. Yes, you two are all correct. So I'm sorry if that was not recorded because there was no mic, but I'll talk about that anyway. So yeah. So the importance of, yep, it's there. So yep, being predictable is that you are reliable in the team. You are reliable, you are trusted, and you deliver on time. And what happens is that everyone loves you in the team. Everyone feels comfortable working with you because you are predictable. You don't shut down your game servers in the middle of a day and run and scream and asking managers, hey, I fucked up, 10,000 players were there and I turned off a game server, help me. You don't end up into that position because you are predictable. You tell your manager that, hey, I never released a game server. Can you help me? Because this is very important. If I fuck up, then the whole concurrent users are going to go down. Trust me, I faced that. Like, I didn't do that, of course, but I've seen that. And what happens is that during those kind of situations, it's so embarrassing because I wouldn't say, I'm saying embarrassing because when you do something, you push a button, all of a sudden you see multiple Slack channels, ding, 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 beeping like hell. And in the whole company level, because not company, but in the whole tech level, DevOps, managers, producers, they're all subscribed to that channel and shit. Okay, you don't want to be that person. Right, so you have to be predictable because again, that is what predictable engineers do because they keep the transparency open, they're reliable as you said, and yep. So the tip is that communicate clearly with your team about your progress and roadblocks because that enables and makes you as a predictable engineer. Now the question is how to provide more predictability. So being consistent and accountable, it's changed, sorry. Being consistent and accountable on your deliverables makes you more predictable because you know what you're doing. So you tell the production team, your team, all the team members that's depending on you, you say that, okay, I take the accountability and I will do it in this time frame and all those things. You are consistent. So yeah, you're more predictable now. You avoid distraction. Oh boy, that's like a very important fact. While I do this, why don't I fix this part because this is gonna be awesome? No. We shouldn't do that. I've done that a lot personally, and I hate it because what I do is, let's say I'm fixing something or I'm adding a new feature. While I do that, I saw that, hey, if I put a new particle effect here, that was way out of the scope. But if I do that, that makes it awesome. And I was like, oh, I do this particle. And then I was like, I need to add some SFX as well. So I go to the Google and I just want to pick up some dummy sound so that I can show it to the stakeholders, but I waste my time there again. And while I am searching Google to find some sound effect, I end up in YouTube searching crocodile versus alligator. What is the difference of that? Shit. Now I don't know the difference and I keep on searching. And there you go, you're distracted. Don't do that. So avoid distractions. That's like one of the personal things that you need to do. You don't task switch. You don't overthink. You don't have to be over perfectionist guy. Just don't be a robot. Of course, you're also a person. You're going to put your feelings and love into your code. But be predictive that, okay, guys, I'm doing this, but I think we can do this bit more. Can we also do this stuff? Communicate with the team so that you're clear that what you're doing and all those things, and your team is not expecting you. Let's say your team has deadline for tomorrow and you're still searching crocodile and alligator, what is the difference? No, you don't do that. So you communicate with the team that, hey guys, while I'm doing this, I thought this would be a nice idea. Can we do this? You talk with them. You will have some back and forth. It's fine. And also you need to be a master at task scoping. Estimate time and complexity for each task, and also regularly reassess and adjust the scope. As I said, readjust the scope, because whenever you assess something, you calculate something, you figure out, oh shit, this is a legacy code and I cannot do it like the way I thought, because maybe you never touched that code, or maybe it's written by some noob, maybe it's written by someone who you hate but you cannot tell. It's fine, but what you can do is you can regularly reassess and tell the team that, hey guys, I thought it's gonna be this easy, but it's like my biggest nightmare now. Can I take 2 more days? Why you do that? It's not gonna make you look bad in the team. What happens is that your production team, if you're in a mid-sized company, if you have producers, all those people in your team, they will be able to know that, okay, this feature is going to be delayed by this bit, so let's do something and do this instead, because what they are going to do is, you're not working on one feature in the company, there are like parallelly more other things going on. What they were planning is like, your feature is going to be coming next, then there's another guy, then there's some other event going to be running, some live ops thing, all those things going to be there. Just because you missed the deadline, they are all waiting in the pipeline. If you say that early, that, hey guys, I think this is going to take a longer time, your production people, your producers will know, your project managers will be reassessing the roadmap so that nobody gets affected and everyone is happy at the end of the day. Also, you're going to be happy because you're going to ship codes that is bug free. You're going to be shipping code that you're more confident and comfortable with, and everyone's happy. All right, so time boxing. That's like when you task scope something, you also need to time box, because if you spend on one task like 2-3 weeks, that's a bad idea. Because at some point you're gonna get distracted, you'll start procrastinating, you'll start having nightmares as well sometimes. Don't do that. I have done that. My wife suffers the most, I'm sorry. But yeah, this is something you shouldn't do, and you should time box, always. Spend 2 hours, 3 hours, let's say, okay, I'm gonna have a coffee, I'm gonna warm up, and I'm gonna do this for the next 2 hours, and let's see. Once you're done, or if you're not done, if you need more time, get a fresh air. If you don't smoke, just walk a little bit, and then again, sit down, time box that, okay, next 3 hours I'm gonna do this. Now what happens is that you're more consistent, and you also have accountability, and now you're better predictable. All right, so the next one. It's almost a similar thing, but it's being reliable. That's another keyword. So yeah, what does reliability mean? Reliability is, what I say is that it's consistency plus accountability, as I said before again, because being predictable is how being clear with the communication, but being reliable is a little bit more, because you're also someone who is consistent with high quality deliverables, no matter what feature, what bug fix. For example, I will give one personal example in my life. I'm not bragging, but what I did was, there was one bug in our code that was there for like 1 year. And it was a very complex code, but what I did was, with all my personal experiences and all my gatherings, because of my investigation, how it led me to the root problem, what was actually causing that bug. I cannot disclose the details, but what happened was, just imagine a bug there for 1 year, and everybody is trying to cut the branches so that you don't have that much, but you still have that bug. What happened was, we fixed it once for all, and because of the high quality code that we were able to produce there, and because of the way we tackled that issue, it's not there anymore, and the game is like also it's been like a year now without that bug ever coming up from any VIP or regular users of our game. That makes me reliable. That hey, Jisan did that fix. I know Jisan can also do that. Now Jisan gets assigned to another fire, and yeah, he needs to also do something like that. But that makes me also reliable in the team, that they know that whatever happens, we can trust Jisan that he can at least give some output that is going to be positive in return. I was able to do that, and that is also reliability as well. Because I think what makes me reliable there was my accountability to that task, that I have to fix it no matter what. Something like that. And that is the accountability I was talking about, that ensures your team that can depend on you. So the tip is that set clear expectation, over-communicate rather under-communicate. For that bug fix, I had to run into rooms with production people, producers, also the customer service team and all those people, because the VIPs were getting into that trouble a lot more. So I had to see what VIP and when. I had to investigate a lot. I was over-communicating here and there than writing code. You know how many lines it had to, for me to fix that was like one single class. It was just one Boolean function that set it true why it shouldn't. That's it. That was the bug. And we never went through that because we thought it was working well, and there was no reports in any of our pipeline that this was faulty. So yeah, accountability. The last thing is being consistent. Again, the same thing, but a little bit more. You have to own it. Own whatever you're doing, own it like it's your thing, it's your company. If you take that much of ownership into something, people in your team, no matter what size the company, they're going to see it, and you're also going to be visible to them that this guy owns the shit, and this guy knows that whatever happens, he will be accountable for that. And that's one of the best things that you can do to yourself. Because I'm sure we all love games here. We are here because we love games. We love making it. We love playing it. So we also want to own it. And I can say that, hey guys, in that game, that light you see, I made that. Okay, maybe you didn't see that, but in that corner of the world, big world, I made that light and I'm proud of it. That's great. But you have to own it, and you have to be happy about it that as well. So that, if you do that, automatically you're going to be product oriented. What happens is that in my previous experiences, I was making some board games. That's a real-time multiplayer game. It's a big game. I was like, what the fuck? These guys have customer support team for a board game? What? I didn't know the scale of the game because I didn't understand the product at that time. When the kids were like, hey, uncle, you make games. Why don't you make Call of Duty? I was like, no, I make board games. It's fine. I own it. I'm happy about that because at some corner of the world, there's some uncle or aunt, they're spending tens and thousands of money into my game. So yeah, I'm happy. So what happens is that when I own it, I'm also going to be product oriented, that I am focusing on the product. I want the better of the product. And if you think in that way as well, you will automatically come up with something that makes your deliverables much better. Much better. So once you do the first two steps, then the third one comes, that ask the right question to the stakeholders. Because you love your product, you're going to be asking lots of questions more often to the product team that, hey, why are you doing it like this way? Why? But we could have done this in this way. I don't like the progression formula that you wrote. Maybe it's going to be better like this way. Why don't we do that? So you're going to be asking more questions, and that's great because you understand product more. That's also going to help you to think broader perspective as well. As I said before, you need to think broader, act and influence based on that. And that makes you grow as an engineer too. All right, so I am almost at the end of my talk. So the key takeaway is that be predictable, reliable, and consistent while growing your technical skills that I also mentioned before. Thank you. So I left 15 minutes for the question and answer. If you have any question, answer, it's the perfect time.
Hi, thank you for your presentation. So you mentioned at some point that it's different when you're doing software for games or for other applications. And yeah, I understand that. But is there any specific books or something, content online that you suggest for people to investigate that more and see patterns specific for games and other things that you would say it's useful?
That's a great question, actually. Even I was looking for this kind of resources for a long time. To be honest, I didn't find one place where you get all the answers. It's scattered around the internet, but thanks to those Indian YouTubers again, I really love this guy who's called Gaurav Sen. He used to be, I'm not sure if I should be promoting, but he used to be a system engineer, and he makes a lot of system design videos in the YouTube. If you search that, that guy explains a lot of things about system design, and I learned a lot of system design principles from that video personally. And once you follow that guy, YouTube will keep on recommending similar stuff, and I learned from that. But there's no one place where you can learn it. But what I would suggest is that keep following people who are focusing on system design or system architect guys, because they have already been a great engineer. So now they're like system architect, and they knows those kind of things.
Gaurav Sen?
Yeah, we can talk after
Thank you.
this. Yeah. Any other questions?
Actually, yeah. First thing I wanted to say, there will be the Q&A section somewhere there. Yeah, if you cross this hallway, somewhere there is the Q&A section. I have no idea where it is, but I've just been told it's there. And actually, I have a question for you. Like, does it also happen to the programmers? Because I'm looking from the audio designer's perspective. Does it also happen to the programmers that if you're self-aware, you have this beautiful mindset of growing, developing your skills and whatever, you end up as a manager?
That's a great question. So personally, what I would say is that if you don't want to be a manager, you need to set the goal clearly to your manager. Because what happens is that I've seen people leaving the company because if they're a senior, once they go to the lead, their job responsibility flips. You're coding like 40% and 60% is managing, or 70% managing. Now you have some other responsibilities that you don't want to take. That's fine. You need to communicate with the company that, hey guys, I want to grow, but I want to grow in this path. I like managing people, but I want to do more of the stuff that is like that I love doing. Sometimes you can find a peace with your upper levels stakeholders. Sometimes you don't. But yeah, we also struggle with that. I've seen people doing that as well. For that kind of path, we have something called staff engineer in our software engineering term. Staff engineer, principal engineer, all those things, they are like God level programmers and something like that. But you can grow in that path, or you can also become a manager. That's like the two paths. Usually that's common. If anyone else have better ideas, you can please tell me. But yeah.
Thank you. Okay, do we have any other questions here? No questions. If you come up with any questions later, please talk to Jisan. Let's give him a round of applause.
Thank you. You can find